Hello and welcome to Haskell for Dummies lesson 2. So in the last lesson we went over how to set everything up, get everything going. We had a little dive into the REPL and to the GHCID. So if I demonstrate, here's our GHCID running, so it's like a watch, and the REPL will go into here. Here we go, so we're inside the REPL and we quickly demonstrate that we can run some func hello you and you, which is what it does. It does is put string line into hello you and you. I'll also demonstrate if I change that to just put string and reload, if I do, you'll see how it doesn't create a new line. Let me zoom in a little bit to make more sense. When I did it the first time round, it went here and then it jumped to a new line, but when I've done it again, it's oh, it's messed up a little bit. Let me just do it again. Here we go. So when I've done it again, it says hello you and then it starts again. So it is not creating a new line. So that's the difference between the two. And we'll reload that. Okay, so we've got that. But let's explain a few things because I didn't really go into the functions themselves, how you write them and their standards in terms of alignment and what each part means. So generally you want to declare a name of a function like this. So some func, it would have to be lowercase. The first letter can't be uppercase, you'll see. It creates an error. Uppercase is saved for types. So that would have to be lowercase. And then it's followed by these two colons, which indicates that it's going to be what type it is. So in this case, it's IO of unit. Then below that, you'd name your function again, and then you'd put an equal as to the content of the function, and in our instance it's put string line hello you and you. But if we make something like triple, we'll copy this example okay, so it does an int to int, so it takes an int, so let's call our int an x, and then we're going to say x times 3 because we want to triple it. So what we'll do now is we'll reload and we'll do triple, oh 1p, and that does 9. So how is this working? So essentially it's replacing the x with a 3 and it's doing like this. Okay, so that's replacing it, so you get 3 times 3, which then equals 9. So that's a bit of an explanation of what's going on, and that's why I explained that the capitalization matters. The function needs to be in lowercase. So valuation, what it's actually saying is these values won't execute until something comes in. When it's like this, it's in weak head normal form, and then when it's evaluated, so when another int comes in our case it was another 3, then it's in normal form because it's been evaluated. So we'll ignore that for now. I'll explain that later what the backslash is. So infix operators, so this is a good one. What you can do is if you see, oh actually a good example of showing that is sometimes if you want to search, like before we were looking for plus plus, so if you type plus plus and search for it, that'll work, but generally can you see it's wrapped in parentheses. So if I press enter, there we go, and that's what an infix is. So let's have a look there, and what this means, here we go, it's the infix r of 5, and what this essentially means is this: add me, that'd be an int to an int, and add me will take an a, and it will be a plus 10. Okay, so you can do it like that, but you can also do it like this, because a, in essence, it takes a list of a and returns us an a. So as you can see, what we're saying is, as when you're using add me, let's give you a little example. So let's reload that. Add me 4, that should give us 14. Okay, so what it's saying is that value int is our 4, And then in that case, this first value is, so let's get the types actually, because that make a bit more sense. And we'll do plus is that type. I'll hide that away. So the A will be this, and then the 10 will be this. We'll explain in terms, because later I'll explain that it actually also becomes this. But that gets a little explained why it becomes like that. But if we just take it like this, so that's what an infix is. You're essentially saying that you can use this in this way also. There's alternate ways to use that. Okay, so that's the infix operator. Let's have a little look at an example. This is a good one, dividing. So we'll call it divme. Actually, let's create a new function. Divme. It takes an int and it returns an int. And there's our int. And then we'll do a, and this is another way to infix, backtick, and we'll divide by 2. Divme, let's call this divme by 2. That's a bit better, isn't it? Divme by 2, give it an A, div 2. So let's have a little refresh. Let's get the type of div. So let's ignore this little part for now. It takes an A, another A, and returns us an A. Well, and the A's are constraint to integral, but I'll explain what this little part is in a minute. Let's ignore that. But for this instance, you can see, so it's readable like this. So you're doing A divided by 2. So if we do div 10, no, if we do div me by 2 10, then that'll return us 5 because it's doing. But when it's not in an infix position, to get the same result, you'd have to do it like this. So let's refresh that, and we get the same results, 5. Okay, so that's what an infix is, and you'll find that a lot of the times, if you are searching for something, it can be easier to search for it in an infix, like this. And there we go. So you can find bits and pieces in the infix. Okay, so that's an example of that. And then we've got associativity and precedence. So it's much like all other languages. Things will take a specific associativity. And to demonstrate that is you can find out the info. So let's type that in our REPL. You can do shortcut I, and we'll give it the infix. There we go. So it says it's an infix of 7, and that's the function name, star. Okay, so that's an infix of 7, infix L of 7, sorry. Okay, so let's explain what so the infix L means. It's an infix operator, so it's left associative. The 7 is a precedence, so the higher is applied first on a scale of 0 to 9. So sometimes you get infix L of 1, and then obviously 7 will take precedence of that, and then that's the name. So the star would be a name. So if we do info of plus, then you'll see that's got an infix L of 6. So that's got a lower precedence than star has, or times. So that explains what an infix is. I mean, it does. You can demonstrate that by doing it straight in here. So 2 plus 5 times 6 is 32. But then if you were to do 2 plus 5 times 6, that equals 42. So you can see what it's actually doing, because the star or the times is high precedence, it's actually combining it like this. Okay, so that's got higher, so that takes priority, and then the 2, so it will bind those together, and then it will take the results of those 2 and then add 2 to it. if you get to a point where you're going to make libraries, then this will be useful. But as for a beginner's point of view, it's just knowing that you can find out the precedence of something just by looking by info. So, you know, if we did the I shortcut in I, but info will work too. And then we can look at plus plus, for example. There you go. Okay. So when we write values like this, it doesn't matter what order these functions are set in, because GHC will load everything in the file at once. But then if you try and do the same in the REPL, it does matter. It's going to be sort of one at a time. So if you're going to declare a function, so let's have a little example quickly. Okay, let's make a create a function, func1, and that'll be int to int, and then func1 a plus, let's do a plus 2. Okay, and then let's do func2, whoops, and it'll be int, well, actually let's just call it 2, and that would equal 12. Okay, so if I reload it here, actually let's make a third function, 3, and that will just result us in an int when we call it, and that would be func1, and we'll pass it 2. So you can see, let's actually put this in a different order for now. So we'll put that above these two, so it's clearly using something that's from below, and then we'll reload it and we'll call 3, and you'll see it'll give us 14. So that's, it takes the 2, we've passed a 2, which is 12, into func1, so that becomes 12. 12 plus 2 equals 14. Okay, but if we're to then do this inside the REPL, and we're to try and do it the same way, so let's say we do, let's make a function, so we'll call it f1, actually we'll call it f3 equals f1 f2. Well, they're not in scope at the moment, there's nothing in scope, so it's not going to find them. They already have to exist to then be able to use them. But here in essence, if those weren't there, if we were to call this ones, for example, save it, there we go, it's saying I can't find func1. But in terms of its order, it doesn't really matter. It's just the fact that it can't find a function that doesn't exist. That's the error we're getting, so we can save that again, and that's back to all good. Okay, so now we're going to talk about a let. Because sometimes you want to declare things that are going to stay inside of a function. You don't want it to be outside of that function. So we can do it like this. So let's take this 3 apart, and we're going to do it like this. So we'll do a let, and we'll call it func1. Takes an a, and it does a plus 2. Then you've declared a let block. You want to align with the function above, so we'll do a func2, and that was just to equal 12. And then you want to use a keyword in. What I'll do is I'll delete that. So as you can see, right, we'll reload it, and let's try and use func1 12. It's not in scope. So this func1, because we've declared it here, it's only available from within 3, and then you can see we use it here. And same as func2. But if we called 3 itself, then that'll work. So you can see how in the encapsulation is sticking within, and you're doing let in, and that's the keyword. So you can see, oh, I mean, they've even put in like this. But you can have it both ways. It just depends stylistically how you like it. Oh, like that, yeah. Okay, this is showing you a declaration, and something like that would break. So look, so it was x equals 10 times 5 plus y, and then y equals, oh yeah, y equals 10, and then let's have my result equals, let's change it a little bit, x plus y, and we'll save it. And it's going to complain straight away saying, well, I've not been able to pass it, there's something wrong here. So if you want to declare a function, as soon as you go on the new line and you have it the same level as the name, so the same indentation as the name, then this is going to be a parse error. It's just this could be somewhere here. You see, so it's a totally different function right now. It's taking this as a function, and then it's not finding an equal, so it's going, well, what's going on? But if we were to do it like this, then that would pass, you see. And then if we were to do, if we were to reload that, and then we do my result, and it'll be 70. 10 times 5 plus y is 60, and then 60 plus 10 is 70. That's that part. So you've got to be careful with your indentation. You can do this. That's fine. That's fine. That's fine. I mean, that's not very pretty, but it can count. Okay, one thing I've not explained is how GHC automatically infers types for you. There's a more technical word for it, but I'll demonstrate what I mean. Okay, so if we find out the type of x, and that'll give us an integer, so it's saying that x is an integer. So it's saying that x is an integer. Let's do that. Okay. Okay. I'm just doing that so it reloads up there. It didn't seem to jump. So it's automatically inferring what our types should be. But just remember, you don't necessarily need to give types. You're leaving yourself open to errors if you're not going to declare the types of something, because GHC will infer them for you. But what if it infers into an incorrect type, and then for some reason you've got two types that don't match, and you expect them to match, and then you're opening yourself to a whole load of trouble. What we tend to do is give everything types, so like that there's no mistake. The compiler has a really good idea of what values should be. Okay, so if we go to the next part. Oh, here we go. Okay, so that's just our operators and what they do. So obviously the plus is plus, addition, minus is minus, subtraction, multiplication for the asterisk, I called it star, asterisk, slash, fractional division, divide, there's div, mod, quote, and remainder. And we'll go into those actually. Let's have a look. So we know how obviously plus works, how times works, how slash works. So that's a fractional division, and then we played with that. Modulus or mod, quote, and remainder. Aha, another thing to remember is because we can't simply do that. You have to make sure you wrap it. Because if you think about it, it infers that to be minus, and if we look at the type of minus, see, it expects two values, but then if we're just putting it in there, it's saying, okay, well, I want the first value and then I want the second value, but then you're giving it this as a second value, and then it's just getting confused. So remember, you want to make sure if you do a minus is to wrap it around, and then to make it really implicit what it's going to be. Okay, we'll skip by this. Oh, aha. Okay, so we had a little look at let before. This was quite good. Here's our let. Okay, I'm going to delete those guys because they're probably not needed. And let's make a where func. Where's our func? And this can just return as an int. And then there's where func, and that equals, let's do yeah, f1 plus f2. Make sure you tab it across, or I do it by 2 spaces, and then you can do this. So f1 equals 12, f2 equals 10. Okay, let's have a little look what happens here. We'll reload that and we'll do our where func. 22. So we're doing 12 plus 10 is 22. Let's have a look what happens here then. So we're again, much like the let, you know, let's have a little look. F1. Nothing. It's not in scope. Okay, so it's again, it's encapsulating things. It's the same version of this, but what you end up doing is declaring your functions below within the actual function itself and then using it above. So what this is called here is a where clause. So once it's gone past this section, whoop, now you're within the where clause. The other useful thing you can do with where clause is this. You can give it type definition. F2, and that's an int, like that. So I mean, so a lot of times you'll find if it's functions that aren't really going to be usable, or you don't want them to be accessible outside, a lot of this will happen in here. The great thing about this is you're making sure that these are scoped to only inside of where func, and then you're not exposing them outside. So it's very similar to this, but it's inside, and you can also give them type definitions. So I mean, if I try and give this a type definition, it won't work, which I'll demonstrate. Func, whoops, 1 is an int. Okay, there we go. So it's just not recognizing it. It expects just it to be a function. So let can be nice if you're going to do like little tiny things, you know, functions you know what you expect them to be. But for readability, it's nice to have the ability to do this. So then if you've got more complex functions that you don't want to be outside of this scope, then at least you can give it a type and you know what to expect. Okay, another cool thing with both of these is if you declare something up here. So this is an extra value that's going to come into our function. So we're going to add the results of them two with a C. Okay, so that'll work. Let's have a little try. So that's 3, and we're going to give it a value of 4. And that'll give us 18. So it's 12 plus 2 is 14 plus 4 is 18. And if we try and do the same here, so it takes an int. Whoops, returns an int, and we'll give it that as C, and then we'll do 12 plus C. There we go. We'll reload that, and we'll do where func, and we'll give that a 2. It'll be 24. 12 plus 2 is 14 plus 10 is 24. Okay, so we've still got access over here. But if we try this, let b equals 11 in like this. Okay, so we've got a b that's not being used, and then we'll try and refer to our b. It's not going to find it. Okay, so what you've got to keep in mind is where clauses can access top level inputs, but it can't access anything that's declared inside the function. But this can. So you see how it's accessing these two functions, they're within, but this doesn't. Okay, so once it's in a where clause, anything that's declared inside of where function, i.e. b, it's not going to find it. It's going to say, well, I haven't got a b in scope, because these essentially act as little functions, but the only access they've got is up here. That's the only access they've got. They don't have any access down here. So here we're essentially doing the same as this, but we're then defining our functions, these two functions, to exist in the where clause, and then we're able to define the types for them. Okay, so I've demonstrated that. Right, well, I think that's potentially enough for today. So I've explained a little bit more about functions, how they're laid out, and what you can do with them. We've had a little dive in with a type declaration. We've not quite explained what this is, but that'll come. So, you know, we have something, we expect it to be an input which sits on the left, then we give it an equal, and then an x plus 3. That's quite understandable. Here's the same. And then we also explained, you know, the infix operator. So you can infix things, or if you wanted, you could have them in here. Obviously, you take that one away. Same with a div. The ones that are worded tend to be infixed like so. Boop. Okay. And then we explain what infix is in terms of like its infix L and in terms of the number it can be. Then we went into a let function. So you have to use a keyword let. You declare a name of a function. You can have multiple functions if you want, so you can keep going. But then at the end, when you want to actually go into the body, you have to do in. Okay, so you do let in, and then we're using anything that's above to do that. There we can get scope to here and here. But when using a where clause, it's very similar, but we don't get access to anything that's in the body. So here we're able to use anything that's below, so any of these two functions. But if you're going to want to pass it, for example, if we want to get access to B, we'd have to do B. That would be a B, and it'd be expecting an int and an int. Let's do like that, for example. Whoops, we have to give it B here. Oh, I've given it the wrong place, sorry. And B here, like that. So then we've got access to the B, you see, but this, you know, we could call this Z. It wouldn't really differ. So now that's the only way we can get access, is by specifically passing it in. But if it's not passed in, then we don't have access to this B at all. Okay, so you just remember that, that's really useful. But then if you don't, you can literally not have the let in there at all. And then we'll get rid of that. We'll get rid of this. Okay, so that's inside our where clause. And I think for today that'll do. Into the next lesson, we'll be looking at printing strings and a little bit more into functions and how they work, and potentially currying and things like that. Okay, well, I hope you enjoyed this lesson, and see you in lesson 3. Thanks.